So today we will start the chemistry topic of coordination chemistry. See, the coordination chemistry composed of complex compounds. That is, they are not like normal salts. In case of normal salts, we can dissociate two different parts of the salt called one is acid radical and one is called basic radical. When one normal salt dissolves in one solvent, it will dissociate into these two parts, acidic radical and basic radical. But in case of coordination complex or compounds, it is not like in the case of normal salts. As we all know in our previous or basic concepts of coordination chemistry, that coordination compounds comprise of two different entities. One is having a primary valency and along with this primary valency there is one called secondary valency. Like in coordination compounds, one is called coordination entity. This coordination entity can be written in this square bracket, and outside this square bracket there may be some elements or maybe some ion or atom or something which will satisfy the primary valency. Here the central metal atom is iron. Around this central atom there is some CN ligand is attached to this central atom with some coordination bond, and outside this there may be some anion may be present outside this coordination entity. And what happens in this case is that when we dissolve this coordination complex, it will dissociate like normal salt, like it will dissociate into and Cl minus. This is similar to normal salt, but we can see that the coordination entity present in this coordination, that is square bracket, will not dissociate into two parts. Like so, why it is happening? Because the type of bond present in this coordination entity is completely different from that of this primary valency bond. Primary valency is like sodium chloride. Suppose the salt is sodium chloride. Here the sodium is present in the form of sodium plus ion and chlorine is present in the form of chloride ion, that is Cl minus. It will dissociate because the valency is similar to this type of normal salt. This is called primary valency. And here again iron is having bonds with this cyanide ions, but it is different from this chloride ion. That is why, as these bonds are different, that is coordination bond, it will not dissociate easily like normally. So this type of valency, that is iron having with cyanide, is called secondary valency. This is a basic concept, and if somebody is totally unaware of this basic concepts of coordination chemistry, then brief summary for them is that we have different types of chemical bonds, but the coordination bond is different from this ionic and covalent bond. The main two bonds of chemical bond is like one is ionic bond and second one is called covalent bond. What is ionic bond? Suppose two elements A and B are having some chemical attractive force in between them. The attractive force is called chemical bond, but the bond can be of different types by sharing or by donating electrons. If suppose A is donating one electron, that is minus electron, and A will become A plus, and B will accept that electron and B will become B minus. A is called a cation and B minus is called anion. And we all know that positive and negative will attract each other. That's why they will form this electrostatic force of attraction in between them, and that is called ionic bond. But if A and B both are having some chemical attractive force in between them by sharing of electrons to get occupied valence shell. That is, suppose A is having one electron and B is also having one electron in its outermost valence shell. And to get stabilized or to get fulfill valence shell, A requires one electron and B also requires one electron. Then what they will do is that they will share these two electrons in between them, so that at a moment B will show like it is having two electrons in its valence shell, and at the same time A can also show that A is also having two electrons in its valence shell, that is they have completely filled valence shell, and that's why they are stable. And this sharing of electrons in between them binds these two atoms, and this attractive interaction is called covalent bond. Covalent bond. And we all know that ionic bond is stronger than covalent bond because electrostatic force of attraction is associated in case of ionic bond. This is called covalent, this is called ionic. These are the two basic forms of chemical bond. And then it comes coordination bond. What is coordination bond? It is available in coordination complexes. And in case of coordination bond, one entity, suppose A, having two electrons, and one entity called B is forming a bond with A by accepting a pair of electrons from A. This type of bond, that is by donating a pair, at least one pair, not less than that. It can be more than one pair, but it should come in pair, that is in even numbers. Even numbers. That is, in this case, A is donating a pair of electron to B. This type of bond is called coordinate or coordinate covalent bond or simply coordinate bond. Here, in case of coordination chemistry, this complex compounds have this type of bond in coordination entity. Here we can see iron is fulfilling its secondary valency with 6 cyanide compounds. In this case, cyanide is called ligands. The entities which are donating at least a pair of electron to a central atom. Most of the cases, the accepting entity in the coordination entity is a metal cation. Metal cation. Sometimes it is called metal cation. Sometimes it is called a metal ion, or simply the central atom. The central atom. If central atom is accepting a pair of at least a pair of electrons from some entity or compounds, the compounds is called ligands, and these compounds can be atom, molecule or ion. These are all called ligands. So the basic definition of coordination compounds is that these compounds do not lose their identity or break down in solution. That is, I have already mentioned that these compounds do not break down in solutions. Like normal salts, they do not break down in solutions.